from operations
4.6.
Yeah.
with
What do you do?
complex numbers.
Oh, it is?
Well, it says 4.8 at the top, so I was thinking it's 4.8.
Did I just accidentally write down the wrong one?
Uh-oh.
Oops.
We did 4.5 yesterday, so today has to be 4.6. Solve the equation. Number 4, r squared is equal to negative 624. Alright, so this is going to be a lot like what we did yesterday in some aspects, except for, obviously, we now have negatives inside the radical, which is going to cause a problem. So we take the square root of both sides, so I would have r is equal to plus or minus the square root of negative 624. And then I need to break this down if I can. So 624 can break into what?
312.
Yep. 2 and 312. 312 can break into
156. You know, we're gonna
156 can break into
78. Oh, not 7.
No,
Wait, yes,
78.
I'm sorry. I'm sorry.
2 and 78. 78 can break into
Keep going, Jonah. You got
I don't
this.
think there's anything else.
2 and 39.
it's an even number, so there has to be 2.
Well, I'm talking about like there's nothing like other than
2 and 39.
And then 3 and 13.
Yeah, 3 and 13.
And then those obviously can't break down any farther, so take out groups of 2.
So many.
Cool.
Okay, 2 groups of 2.
So I can take out essentially a 4. So I end up with r equals plus or minus. Now, I'm taking out a 4, but I also need to get rid of this negative inside. To do that, I take out an I. So this is going to be plus or minus 4i, and then the square root of what's left, which is 39.
Hold on, Ed.
Does the I stand for something? I don't know.
Square root of negative 1.
Oh, that's weird. Huh.
And it's not real.
You remember doing this stuff?
If you ever forget, if you look at this poster that's up on the board above where I'm pointing right now,
Oh.
I can help you.
Yes.
Alright, s squared minus 22 equals negative 112.
Plus.
Add 22, so I get s squared is equal to
92.
negative 90.
Nice job.
That was Dylan who said that.
So why are you?
I heard you though.
Yeah, but I was going off what he said.
So why would you trust him?
Shut up.
Alright, what happens now?
Find the square root.
So f is equal to plus or minus square root of negative 90.
Yep, plus or minus square root of negative 90. So break down 90. What does that break into?
2 and 44.
3 and 10. Right? No, 9 and
It's
10.
3 and 30.
Yeah, let's do that instead of 2 this time. I'm tired of doing 2s. Alright, 30.
Now 3 and 10.
Oops.
And then 2.
My head got it.
Alright, so I can take out a 3. I'm going to be left with 10 inside. So s is equal to plus or minus 3. Got to take out that negative, so I. Oh, there's a really long tail on that I. And then the square root of 10.
Well, these are easy. This needs to-
10.
What?
3p squared plus 7 equals negative 9p squared plus 4.
3 squared plus 7.
Alright, so when we have one like this, I need to get everything on one side. It doesn't matter
Push the
which way you want to
9
do it. That's what I like to do. So I'm gonna move the 9p squared over. Well, I'm gonna add it over. And then in the same step, I'm going to subtract the 7 over. So I've got 12p squared is equal to negative 3. Divide by 12, p squared is equal to negative 1/4.
Oh, fraction.
Yay.
Take the square root. P is equal to plus or minus the square root of negative 1/4. So remember, this is the same thing as if I had plus or minus, like the square root of negative 1 over the square root of 4. Remember, I'm allowed to break it up, and it doesn't matter if I put the negative on top or the bottom, I'm going to get the same thing. Do what?
Never mind.
You gotta do
No, you're right.
Oh.
Yeah, just with an I. So P equals plus or minus 1/2 I. Okay, any questions on that before we move to the next thing? All right, so just like when we have terms that have like just like constant numbers, and then we have like terms that have x's or x squared, things like that, we can only combine like terms. Well, the same thing happens with problems that have i's in them. We can only add the numbers that are by themselves and then only the numbers with i's with them. So, number 12. In parentheses, I've got 6 minus 3i plus 5 plus 4i in another parentheses. Now, the main reason they group this is because this is technically like one number, and then like this is like another one, but it's still, you don't really have to have the parentheses because essentially we're going to ignore them. No, standard form is always a plus or minus depending bi. So I'm going to add the terms that are just numbers. So 6 plus 5 is 11. And then negative 3i plus 4i is just plus I. So my answer is 11 plus I. It has to be in that order or it will not be completely right.
I like this one.
14. Negative 2 minus 6i minus 4 minus 6i. So when you have a problem like this one, obviously this other one was plus, so I was just adding the things together. When it's minus, you've got to make sure you essentially are distributing this negative. So as I read it, I read this sign in between the numbers. So I've got negative 2 minus 4, so that's negative 6. Then I've got negative 6i minus a negative 6i, which is what?
So it's just
Yep,
negative
just
6.
0. So then just negative 6 is the answer on that one. um, 16. 8 plus 20i minus negative 8 plus 12i. So I've got 8 minus a negative 8, which is 16. And then I've got 20i minus 12i. So I've got 8i. So 16 plus 8i. Nice and easy.
I can't wait for
All right, so that's adding and subtracting. We're going to move into multiplying and dividing. $22. 6i times 3 plus 2i.
Oh, how is this going?
So in this case, we're just distributing just like normal. If it was just a 6 out there, I would just distribute this. So I would have 18i plus 12i squared. Now, in your notes, did I tell you what I squared is equal to?
1.
Close.
Negative?
Negative 1.
Yeah.
So this is going to become negative 12 here. And so then I'm going to end up in standard form, negative 12 plus 18i.
Why are you laughing? I'm not laughing at you.
So it can't be 18i minus 12.
No.
Nope, it's got to be in standard form. Standard form is always a plus bi, or minus, obviously.
Who you? Kind words.
All right, most of these are
Zero out.
even or odd problems, so I'm just gonna make one up. 2 minus 3i times 4 plus 2i.
Oh, so it's foil?
Yep, so we've got a FOIL one like this. So I have 2 times 4 is 8. 2 times 2i would be 4i. Negative 3i times 4 is negative 12i. And then negative 3i times 2i would be negative 6i squared.
Oh, it's like backwards.
So I squared is negative 1, so this negative 6i squared becomes plus 6 instead. A lot of times I just write over top of it. If you want to like do another whole line, you can do that, but I usually just write over top of it. So now in standard form, 8 plus 6 is 14. 4i minus 12i is negative 8i, and that's your standard form.
Sleeping? No. Give me a warm bottle. I know.
Oh, Addie. 24. 1 minus I cubed.
One minus I. 1 minus I. Oh,
So this means 1 minus I times 1 minus I times 1 minus I.
well, isn't that great?
So I'm going to multiply 2, and then I'm going to get that one, and then I'm going to multiply it by this one over here. Just makes it easier.
Okay.
You'll see. All right, so these first two multiplied together, I get 1.
Oh.
This is technically a perfect square trinomial. If you see that, then I've got minus I, so minus 2i is my middle term of my perfect square trinomial, and then plus I squared.
No, I squared.
And then 1 minus I is being multiplied by that. Now, before I multiply again, I would probably recommend we rewrite this, simplify it down. I squared is negative 1, so that means I've got 1 minus 1. Well, that just goes away. So I end up having negative 2i times 1 minus I, and now I just have to distribute instead of FOIL again.
I keep writing my eyes as ones and then putting a dot on top.
That's why I put like a little tail on my eyes, because otherwise I would totally mix them up. And I do like L's in cursive because I just can't.
The L's?
All right, so multiply this, I get negative 2i plus 2i squared.
And then that's a negative. So it's, yeah.
And then I just got to rewrite it.
Oh, yep.
No, it's backwards. Negative 2.
Yeah, get out.
All right, now I don't remember if this was in your notes or not, so I'm going to write this for you. I is obviously just I. I squared is negative 1. I cubed is negative I. And I to the 4th is 1. And then the process repeats itself over again. So I to the 5th is I, and so on and so forth. So with that information, you could solve something like I to the 29th.
See, but then I would have to go through.
But you don't have to count every time. I can literally just take this and divide by 4 and then see what's left over. So I to the 29th is going to be the same thing. If I divide 29 by 4.
7 and 1/4.
Yep. I don't know why I'm writing it this way, but let's just talk about that.
Ew.
So this means then I'm going to go, and I to the 29th is the same as I to the 1, which is just I.
Okay.
So you're not often going to be asked something that extravagant, but I just wanted you to see that you could do it that way.
I still don't understand how we got eyes.
Yeah, I still don't know.
Where?
Like on the 7 and 1/4. I don't understand
Wait,
how
yeah.
you got that.
Take the wrong.
No, not the 7 and 1/4, like the I1 equals.
Oh, because it would reduce down. So 7 to the 28th would be the same, or 7 to the 28th. Hold please. I to the 28th would be the same thing as like I to the 4th. If I did, because this would be 1, 2, 3, 4, 5, 6, 7, 8, 9,
so
10,
it's
11,
just
12,
like
13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, and then 29 would be back here.
Alright.
Wait.
So you can just skip the
So
whole
you can
dividing.
just-
Okay. Oh, okay.
Count.
Okay.
So you can just count, which for some people is faster, and that's fine. But you can, honestly, a lot of times I just count. But you can also do it this way.
I'm not
I like that one. That's easier.
I do
Like-
427.
So, but I would suggest when you get like your quiz or your test that somewhere on there you write this sequence of I squared, I cubed, I to the 4th, and then write this down as well. I negative 1, negative I1.
Gotcha.
If you say it enough times, you'll kind of just memorize it. But just because it can be helpful to you going forward. Okay. So that could be helpful with a problem like this. 26 is negative 2i all raised to the 4th.
Oh.
Fantastic.
To the 4th?
1.
So it's
So
negative
it's
2.
negative 2.
So negative raised to the 4th is just becomes positive. 2 to the 4th is what?
16.
16. And then I've got I to the 4th, which I'm just going to write this for a second. But I to the 4th is 1. So this just becomes 16.
Oh, okay.
So you're like 2, 4,
I lost my
8.
count.
I just said 16.
I think.
Bro, I'm not good at math.
Because you said your brain was so big.
I said my penis is.
Yeah,
I'm
whatever,
eating here.
or whatever coin crap you said.
Okay, yesterday we had problems where we had to multiply by the conjugate, right? We had like something like this.
Yeah.
You have a few knots.
Something like that, and we multiplied it by 4 plus root 3,
What?
top and bottom, to get our answer.
Correct.
We're going to do something similar with conjugates, but it's called a complex conjugate.
Oh, yeah. Is it
I ain't even
complex?
gonna ask my question. I don't want that.
So 7i over 8 plus I, we obviously, much like, I say obviously, we don't know this yet, much like with radicals, we can't have those on the bottom, we can't have an I on the bottom. I has to end up on top. So, in order to do that, I have to multiply by what we call the complex conjugate, which would be 8 minus I. Because again, like what we did yesterday, I want to produce a difference of squares on the bottom because then that allows it to cancel. So on top, I just distribute, so that would be 56i minus 7i squared, and I'll deal with all that in a second, over 64 minus I squared.
And I squared is negative 1.
Yep, so this is going to become a positive 1 here because I have negative I squared, so negative and negative is positive. So on the bottom, I end up with 65. Up here, this negative 7 I squared is going to become plus 7. So I have, I'm going to go ahead and reorder this, 7 plus 56I over 65. That is not my final answer. It's not in standard form.
Oh.
Standard form, it's got to be split A plus BI. A and B can be fractions, which is what's about to happen. So I'm going to have 7 over 65 plus 56 over 65 times I.
Oh, that's fine.
Oh, so you just split them?
Yep.
Well, why does the I look
Because it has a little tail on the end.
That is so. I don't like that.
What, Cooper?
It's blurry. I'm trying to fix it.
Whoa.
I was trying to make it less blurry. I don't really know if that helps, but.
I didn't think it was
For the,
blurry.
like, the 15.
See, I don't know, maybe it's just from over here. It like often looks blurry, but then like I do that and everybody's like, oh, it wasn't blurry. And I was like, oh, well, it looked like it from over here. I don't know.
I need glasses.
You said it's good.
Yeah, but I think I have an astigmatism.
I have astigmatism.
Alright, 30. Negative 2 minus 5i over 3i.
Great.
Now, when I have this situation on the bottom where it's not like the last one 8 plus I, this is just 3i. All I need to do is get rid of the I on the bottom. So I just need to multiply by I over I, and it's going to get rid of it.
Okay.
So we're not really multiplying by the conjugate if it's just one single term on the bottom.
It's high. Just negative.
So on top, I get negative 2i minus 5i squared over 3i squared.
Oh, oopsie.
Negative 5i squared becomes what?
5.
Yep, plus 5. 3i squared becomes
Negative 3.
negative 3. And then I need to reorder this. I can go ahead and split it all in one step. I'm going to end up with 5 over negative 3, or you could do negative 5 over 3, it doesn't matter. And then plus, because both of these are negative, 2 over 3i.
That's easy.
When you say that.
What's gonna
We're never gonna
what's
get
gonna
to
get me
the
is like
book,
the
but,
eye going off to the side.
Yeah.
I mean, if you put it on top, I'm usually not that as picky about it. This is just technically standard form, but it on top is no different than me writing 2/3 x or writing 2x over 3. I mean, ultimately.
I have a dream.
32.
All had dreams before.
What did you
7 plus 4i over 2 minus 3i. Alright, what's my complex conjugate?
Alrighty, guys. We're gonna drop the
2.
object.
2 plus 3i.
You can't control what you dream.
Alright, so you gotta FOIL the top. The bottom is a difference of squares. On top, I get 14 plus 21i plus 8i plus 12i squared.
Oh, is it the foil thingy?
Yes, I FOILed the top. Then on the bottom, I have a difference of squares, so that's going to be 4 minus 9i squared.
4 minus 9i squared.
All right,
And that's just gonna be
12i squared is what?
negative.
Negative 12.
Negative 12. Negative 9i squared is?
9.
So now I have 14 minus 12. That's 2 over 4 plus 9 is 13. Plus over here 21 and 8 is 29 over 9, and then the I.
Oh yeah.
13.
2 over 13.
All right. Do we feel like we need to see another one, or are we okay?
We're alright.
Okay. All right. Did you in your notes have something about the complex plane and graphing?
Graphing.
Was there graphing listed in your notes?
No.
Okay. We're going to have a brief intermission of notes then.
Huh?
Brief intermission.
No thanks.
All right.
0.6 cents.
The complex plane.
What pen did I use for those notes? Just one.
I'm going to have like some examples mixed into here just so you know. Complex numbers correspond to a point on the complex plane. The y-axis is the imaginary axis. Whoa, can't write. The x-axis is the real axis. All right, so My real axis just counts like normal, 1, 2, 3, so on and so forth. My imaginary axis, though, this is I,
Oh, wait,
this
on
is
my
negative
4.8
I.
then.
11.
Yeah, they are.
This is negative 1 over here, so on and so forth, okay? So negative 2I down here, all the things. All right, so a few problems to go with this, or not 30, just so that we have examples here with it. All right, 34 is 1 plus 2I, 36 is negative 6I, and 40 is 7. I need to change that. I don't have, well, I can make my graph bigger, I guess. I'll just make my graph bigger.
No, that means I was reading my graph.
No, I didn't woke up.
No. I have great tips on
Okay.
the algebra.
All right, so I'm going to call this one point A, this one point B. I erased the 7.
I always like.
And this one point C. All right, so 1 plus 2I, what we do is we go over on the real axis first. So this is a 1, so I go over to 1. And then it's up to 2I. So this point goes right here, and it's point A. 36 is negative 6I. So that means that on the real axis, I'll basically just have a 0. So it's not going anywhere on my x-axis. On the y-axis, I'm going down 6. So 1, 2, 3, 4, 5, 6. This is point B. And then 40 is just 7. So obviously if you don't see an I, that means it's on the real axis. So on the x-axis, I'm going over to 7. And that's point C. So it's not hard. Honestly, people usually like these ones because there's not really any math involved. You just have to remember your real axis and your imaginary axis. All right, we got one more notes thing because I highly doubt this was in your notes either if that wasn't. The absolute value of a complex number.
We should all watch the Rocky.
All right, Z equals A plus BI, where the absolute value of Z is a non-negative. So that means it could be 0. Real number. Defined as absolute value of Z is equal to the square root of A squared plus B squared. This is the distance between Z and the origin in the complex plane. Too far. So I'm going to draw a little picture over here for us to see it. All right, so this is my imaginary axis. This is my real axis. So for the real axis, or well, hold on, let me back up. So this number right here, or this line, it's gonna work.
Wish I
There
could
we
do
go.
that with my pencil.
I try it on paper sometimes, and then I realize, like, oh, I can't do that. My geometry notes look very awful on paper, and then they look really good on my iPad. I'm like, yeah, well, oh well. All right, so this right here is our line, but to find this, we have on our real axis, this is A. For our imaginary, this goes up BI. So this line here that I was finding, or this distance here, is the absolute value of Z is equal to the square root of A squared plus B squared. You'll notice this is a right triangle, and this formula hopefully reminds you a little bit of the Pythagorean theorem. The reason
A squared plus C squared equals.
the reason this is absolute value is because we can't have a negative distance, so it's absolute value. But z is equal to a plus bi, which is what is graphing this point technically up here for us. Okay, so a couple examples of this. 42. The absolute value of 4 plus 3i. This is way easier than it looks. You're not actually graphing this. So we literally just take this number and plug it in for a in this formula. So it's the square root of 4 squared plus this number here, not square root, 3 squared. So it's literally the square root of 4 squared plus 3 squared, which is the square root of 16 plus 9, aka 25, which is 5.
That was easy.
So as long as you remember this little formula, you'll be okay. 44. The absolute value of 10 minus 7i. So when I do this one, obviously I have a negative sign in here. I'm going to put that with it. It's being squared, so it's not the end of the world if you forget. But I've got 10 squared plus and then negative 7 squared. So square root of 100 plus 49 is just the square root of 149. I don't know if that can be broken up or not. I don't think it can. I'm just going to leave it. I think it's fine. 2 doesn't work, and I don't think 3 does, and that doesn't work. Sometimes I just give up after that. It's fine. All right. Any questions on that?
Yeah, like, hey. Oh.
1 second. I'll give you your homework. Okay.
Hey.
Okay. I honestly have no idea. Joe. I mean, I'm sure she's helping some. It's just with her schedule. I'm not sure how much she is actually.
Oh, it's big.
Yeah.
It's so big.
In 2016.
It's 2016.
I played.
Yep, no problem. Bye.
Trust me, we're right, 2016.
I'm so far away.
Holy problems. Okay, study 9. Wait, what time is it?
No. No, the troll face dance.
9:56.
Oh, I thought you meant like it's a troll.
That felt like
Trolls
whole
movie
class.
was peak, bro.
Yeah, trolls. All 3 of them.
Number 3?
I haven't watched the third
I
one.
didn't even watch
Oh
the second
my
one.
God.
I watched the first and the second
What
one.
happened in the second one?
Was that when the maid fell in love
They
with
traveled
the
across the world.
I
Oh,
look away from
gosh.
the sex.
All right, here's your problems. I know it's a lot, but they're really not that long overall. These 4 problems right here are just 4 points to graph on one graph. These last 2 are your absolute value problems. So it's really just the other ones. But this is a different concept that's not something you've probably done before, which is why I want you to do more of them. But you have some time now, so you may have a little bit of homework tonight, but I think you'll be okay.